Our next presenter is Donnie Beaver. He's CEO and co-founder of HalenHardy LLC, based in Bellwood, Pennsylvania. Mr. Beaver has spent the last 45 years focused on two main areas: controlling and cleaning up oil and fuel spills, and conserving trout streams for future generations. In 2013, Mr. Beaver founded HalenHardy with his two sons, Josh and Troy, and his long-term business colleague, Carl Cohen, with the mission to develop and discover tools to tackle crappy jobs safely. Donnie's innovation and entrepreneurial skills have been recognized by a long list of awards. And today, Donnie's going to be discussing new technologies for floating and non-floating oils on small inland waterways. So Donnie, if you're ready to pull up your share screen and optimize for video if you have video.
Let me grab share screen here. And need to go to present mode. And the video's all voiced over. So if you can hear my voice okay, we're probably good to go.
Yeah, we're good to go. Thanks, Donnie.
Great. Yeah, following Vince and being in front of Sean, I feel like a pair of hush puppies in a room full of tuxedos, but you guys are working on some really massive and cool stuff, and we sort of dink around at the other end of the spectrum. So basically, I'm at the intersection of inland, where water meets oil, and a lot of times it's where stormwater meets oil before it gets to an inland body of water. To Vince's point earlier, that it's better to head it off at the pass if we possibly can. And so that's a lot of our efforts are focused on preventing it from getting into waterways, and then helping once it does. The first video is talking about this intersection, and I just about flunked out of high school physics. Really didn't see any use for it until I got into the world of cleaning stuff up. And so we decided when we started HalenHardy that to create our own little torture trough as a way to test the popular spill control materials that are used on land or inland. Clay is first. This is our torture trough is 16 inches wide. It's about a gallon of water a minute at a 5-degree slope. And you can see the stuff fails right away. It's no surprise. What was a surprise to me is that over 70% of all spills seem to happen in wet weather on inland side of things. And the same thing is true with white spill materials. They hate water, so the oil floats up and over or around or moves the product out of the way. So we decided that maybe we'd go back to the drawing board, and instead of trying to fight Mother Nature, we'd work with her. And so we noticed that sheet flow is normally about 1/4 inches deep in an average Pennsylvania rain event. And so when we started to do the physics of why is this stuff not working, we realized pretty quickly that a 3-inch sock only has a 1-inch bottom that's in contact with the surface area of where the spill is happening on land. Now in the water, it would be the facing side of it. But again, because most of these materials are made to float, which is really good if you're in a body of water, but on land, it's not good. No matter how you try to position it, they just want to float out of the way. And even once positioned, there's always nooks and crannies where the oil can sneak around, since the oil floats on the water, and it just finds its way to the path of least resistance and down the drain. And so we came up with the term flat's where it's at. We needed more surface area. We needed a material that would allow water to filter through. And then, so we found some fibers. Actually, we found recycled 100% post-consumer waste that would hold back the oil and keep the oil on the upstream side and let the clean water filter through. And so my friend Albert Einstein comes into the equation again, and we said, all right, so just how thick should it be? And we came up with a 1/2 inch sort of arbitrarily at first, because if you notice, the line there represents a 1/4 inch of rainfall. And so we thought if we doubled that, that might be a good place to start. And as it turns out, we sort of lucked out after 3,000 or 4,000 hours of coming up with an 8-inch wide, a 1/2 inch thick that would handle most normal rain events for an inland uh, oil spill. And as we were talking, the more surface area you have, so these particular strips were designed to be 8 inches wide versus the 1 inch surface area of a sock. So you have 800% more surface area, plus our stuff doesn't float, which runs sort of counterintuitive to what most people think about oil spill products, but on land, it's real helpful. And there's a overhead shot of how it works. So I went to work where a lot of our other products were cooked in my garage at home. That storm drain goes into the municipal stormwater system, so I have to be a little careful because everybody knows what I do. So then we started to ask the question, what happens if you have more than 1/4 inch of water? And we realized that we could stack our strips on top of one another and then create what we call a filter ramp or the shingling effect on the upstream side. And so you can see the dry part, the water isn't breaching the dry part, and the oil is held back and the clean water filters out the other side. And so with that in mind, we started to say, what else can we do with this, or what ways can we utilize this? I dare not call it a technology because compared to everybody else's, it's pretty simple stuff. But we thought, well, could we steer a spill with this? And we found out, yes, indeed, we could steer a spill underneath my elbow or the assets that we were trying to protect. And we steer the spill to the ramp where we want to stop it, and we prevent it from going toward the assets. So it's real helpful to keep the oil from going where you don't want it. So we sort of had what we call the trifecta: steering, stacking, and shingling, so that we can shield the drain downstream there from the oil getting to the drain. And then, of course, form follows function. And so we said, what would be the best form to start with? And so we started with a trout stream. I've been protecting trout streams for 40 years. And we said, let's work backwards from the trout stream. Let's go up the ditches and the gullies and through the wetlands. And where does this stuff come from? And most of us know it comes not necessarily from a cul-de-sac, but from a storm drain. And we said, well, let's make our stuff the right size to cover a storm drain so that we could shield it and act as that first line of defense so it doesn't get into waterways. So this is a standard size 32 by 48 inch. We call the material Husky. This is a live in the field situation where you can see the outline of the storm drain is sort of lighter colored and the oil is collecting on the edges. And, it's usually 45 minutes to an hour till a spill response team shows up, but the frontline worker can put this down and sort of at least have his first line of defense in place while he's waiting. And then we took this steer, stack, and shingle idea, and this is a controlled spill, but we have about 5 gallons a minute of water coming down. We put the strips on either side to act as a steering device. We stacked and shingled at the bottom part, and the oil never breaches. And below it, you can see the outline of the storm drain. So we borrowed Ron Popeil's pocket fisherman, or no, I guess it was the toaster oven or whatever, set it and forget it. Then we discovered something else. Our materials were highly compressible. And so we thought for frontline workers, it would be pretty cool if we call it smooshing, smoosh them down. So these are 5-gallon spill kits, side by side, typical bucket, typical spill duffel, and then our filtration materials. And we just give you a little unzip tool. That 32 by 48 inch pack is inside. And essentially, it helps frontline workers, seat pockets, underneath the seat, in a toolbox, any little nook and cranny you have on your vehicle, behind the seat of a backhoe, are all good opportunities. And so that was our first line of discovery that we did as we were starting HalenHardy. And then the next was, okay, that's doing a good job of steering it and preventing it, but what about cleaning up? And here is a little pothole in our parking lot. We created a sheen at first. This is used motor oil. We like to use that just to be visual. And then we created also that extra little plops on top. And we take the same material, and because it doesn't float, you don't want to throw this out on a body of water, but on land you can lay it down. And essentially what it's doing is it's allowing the clean water to filter up into the fibers, and the oil is sticking to the fibers while the water wicks through. So you'll be able to see as we flip it over here in a second that that even the fine swirly oil as well as the blobby stuff is showing up nicely. And you can see behind when we lift them up, there's no real visible sheen underneath to speak of. And this is a very small spill. Obviously, all these things have their own capacity. Each one of these, it's about a half gallon. But there was a sheen remaining around the pothole after we got rid of all the water. So this is just demonstrating how the same materials can be used. They're thick and spongy. And so you can basically, without a lot of labor, we call it a few love taps here, just pluck the sheen off the ground down into the nooks and crannies of the pretty badly cracked blacktop. One of our customers came to us and said, well, gee, this stuff works pretty well. We have a real problem with our oil water separator. I'll just let the video speak. So they had a 300-gallon overflow tank for a belt skimmer, and you can see the black oil that was oozing out the top. They had to have a vac truck come in about every 7 to 10 days at $1,200. And when we took a look at it, we saw that the overflow stuff looked more emulsified, and there was lots of little water beads on the belt skimmer. And we just sort of had a hunch that the 300-gallon overflow tank wasn't full of 300 gallons of oil. We thought there's probably a lot of water based on the color differential between what was coming out the top and what was in the trough. And so, we decided to just put a little sump pump down inside, and you can see it's clean water coming almost immediately. Most of the stuff discharged, and we took our filtration materials and we just created a little filter sock here, and we used a sump pump to pump it out. And it took a little over a couple hours, the whole process the first time as we were learning. But you can see the bucket still has some degree of discoloration, but we pumped out all 300 gallons, and you can see the water's gotten clearer and clearer as we're going. And there's a little oil ring. Altogether, we collected about a half gallon of oil out of 300 gallons of in the tank. And but you can see that none of the real dirty stuff got through the filter. And then we put a clean filter pad down, and we decanted the rest of the water. It flows through at about 40 gallons a square foot a minute, so it filters through quickly. And when we lifted that up, you'll see it's dirty on the top and clean on the bottom, and there's the old sheet below it. So this was basically a $200 job, replacing a $1,200 job, and everything was staying on site in a closed loop system, with the exception of the soil pads. And then we said, well, let's make it a little easier. Why don't we build a decanter bucket using the same materials inside of a 20-gallon overpack? It's gotten a little more sophisticated looking in the last 2 years, but when we first invented this, it's just got the right number of holes poked in the bottom to allow the flow to keep up with the materials on top. We've discovered that we do this about twice a month, and so far we've only had to change the filter fabric twice in 2 years. So it's a pretty effective way. It's saving them about $1,000 every week to 10 days, and they don't have to worry about any permitting stuff or the vac truck going through a safety briefing or anything. It's a pretty simple process. And then the same customer saw how well the fibers worked, and he said, can they filter oily suspended solids? And we said, I don't know, let's give it a try. So here is an outfall that goes into a top 100 trout stream 6 miles from my front door. And this is years of oily sediment built up in a rail yard, cinders from my great grandfather's era, mixed in with lube oil, diesel, and Lord only knows what else. And the outfall, they had a white boom. You can barely see it there. It's black now. And they said, that's your challenge. So we said, well, let's clean it out. Let's line the ditch with the material. Let's make a few little check dikes out of our filter material. And just the first day we had it down, we noticed we were starting to collect the oily sediment. A few weeks later, you can see a little bit of sheen on top in a couple places there. We built a filter cover over the inlet to the outfall out of the same material. Good news is their fats, oil, and grease measurements fell back in compliance for the first time in years, and their suspended solids went from 323 milligrams per liter down to 9. So the material does a really good job of capturing the suspended solids, and if it has oil attached to them, all the better. The filter sleeve, you can see the line around it. It gets changed monthly. The material in the ditch itself is on an annual schedule now. It was changed after 13 months the first year. Now it's on an annual schedule. And then the same guy said, hey, I've got some other storm drain issues where we have NOVs over on the other side of the yard in what we call the traction motor storage area. And it's real greasy. Do you want to come over and take a look? And so we did. And essentially what we discovered was the same materials configured a little differently could protect storm drains. So these are above grate storm drain covers that have a durable netting sewn on top, and then they have what we call speed bumps. There's an overflow outlet in case we get a heavy storm so that they won't flood the yard. And then there's what we call little speed bumps that we've accidentally engineered into the process. And we discovered that the sediment and the oil slow down better if you give them a place to slow down. And so we built in these little places to stop it. The other one had a filter sock around it because it gets especially. And then in high traffic areas, they said we can't be running across them with tow motors. So what we did was we removed the grates and we put L channels, subgrate, put some fiberglass grating in, and then put our materials on top of the fiberglass grating. And because it was a 100-year-old storm drain, we had to put some chinking around the edges to keep everything within the confines of the drain. And here's what it looked like on day one. And we basically said, well, let's put it on a quarterly maintenance schedule and see what it looks like at day 90. And there's what it looks like at day 90. It's basically mostly grease, some lube oil, a little bit of sediment, and some yard residue. But again, they fell back into compliance and have been doing that now for, I guess it'll be 2 years in March. So now we're working on my two personal holy grails for an inland guy. Holy grail number one is oily sheen. And so we partnered with another manufacturer to use their technology to build what we call a sheen fence. And essentially, again, for inland waterways, small bodies of water, ponds, small lakes, streams, not too useful in many other applications, but essentially what happens, same deal. The water passes through and the oil sticks to it. And so you can see in this one case, you can't really see the sheen there. Here, this is lube oil on the right-hand side. The other one was diesel. And in both cases, you look at the downstream side and you see nice clean water. The one on the right is a trout stream. And so it goes from sheeny, soiled in the upper side to nice and clean underneath. We can create an underflow dam if we need to out of this material also. And then finally, I'm not going to show that one. That's just how we did it in our torture trough. And then we sort of married the two technologies. So the sheen fence is upstream, and you can see the oily residue there. But because of the time of year, you can see the flora on the sideline, lots of pollen in the air, lots of dust. So it's mixing with the lube oil sheen and dropping out. So we then put our husky material downstream and build a little filter ramp where it's catching the non-floating oil. And there's some stringy algae-like material in there too, but it's also the contaminant-laden non-floating oil is doing that. And the last little slide here is, so we just did this last week. We created our own version of non-floating oil with some Moroccan clay mixed with used motor oil. It's not very scientific yet, but you can see the oil, some of it floats, some of it sinks, but it is collecting after we let the water evacuate through. It's all collecting on the surface of our filtration materials, and the downstream side is crystal clear and no evidence of any contaminants on the downstream side. So that concludes, I guess, my time's up.
Perfect timing. And I have a question to start. Have you done any quantitative evaluation of the capability of this technology?
Most of our customers are in the business of things like electric utilities, pipelines, railroads, and their quantitative measurements are usually if they have a spill and the area is cleaned up, their quantitative measurement is, did I get the job done in half the time that I would have normally? And so we find that to be true in most cases because we're able to have our stuff on the front lines. On the stormwater side, the quantitative measurements are always the measurements that they have to turn in for their NPDES stormwater stuff. So we've seen 100, 200, 300, 400% improvement over their former problems. We're not big at spending a whole lot of time doing lab work. It's like it either works in the field or it doesn't, and if our customers either like it or they don't. So we're not super scientific about that.
Understood. Awesome. Yeah, if it works, it works.
Yeah.
Jenna, do we have any questions?
Yeah, we have a question from James Mitchell. How do you dispose of this filter material?
Well, first of all, that's a good question. The material was already headed to a landfill when we grabbed it. It's basically used carpeting and furniture coverings. And so we deconstruct it, clean it up, and it's 100% post-consumer waste. So we've given it a second life. A lot of our customers use it for waste to energy. You can squeeze it out and reuse it, but nobody does. We've reused it up to 30 times on the same spill. With having a ringer there on site, but most people just don't go through that trouble. But what doesn't do that? It depends on what's contained in the contaminant. So if it's just plain oil and it meets the oily rag rule and it's not dripping, it goes to a landfill. If it's got PCBs in it, it's treated appropriately.
Got it. Thanks so much, Donnie. If there aren't any more questions from Jenna.
No more questions.
Great. Thanks so much, Donnie.
Thanks for the opportunity. Good to see you.